math tutor here. These are step-by-step solutions. I'm going to show you exactly how to write your answers. So we need to do the integral of f of x. F of x is the cube root thing. Cool. So to integrate this thing, well, I just wrote the answer, like to the indefinite integral to the antiderivative there. But a lot of people would do a u sub here. So I also wrote the u sub on the right side of the screen. So, important things here, you set u equal to the inside of the root, and then you want to write the root as an exponent, and then you can do power rule. So once you get your antiderivative, then you plug in the 2, you plug in the 1, right? And there's just like some arithmetic you can do. 3/4 is what you end up getting. But remember, you could just leave your answer unsimplified. You do not have to simplify your answers on the FRQs. Let's see how I wrote my answer. This is how I would write it on the actual exam. I guess I did simplify my answer, but I did it in my head, I guess. Okay, so one final thought about this part, we basically just found the area of region R, right? We found the area of all of this, although they did not phrase the question that way. Anyway, I just think that's kind of interesting. Part B. All right, so let's do volume. Region R is rotated about the x-axis. Is this disk or washer? It looks like it's going to be disk because there is no empty space, right? There's no empty space between the region and the x-axis, the axis of rotation. So it's going to be disk. What is the formula for disk? It's pi r squared, and r is like the radius. I guess I should be clear. Like when I say r, I don't mean like I don't mean like r as in the region r. I mean radius r. Maybe I should make it lowercase. Okay, and then also it's a dx integral. And the reason why it's dx is because it's rotated about the x-axis, right? If it was rotated about the y-axis, then it would be dy. Okay, so how do we figure out the radius of this 3D shape? Well, I'm not going to draw the 3D shape, but oftentimes you can just think of it as like top minus bottom, right? With dx integrals, top minus bottom is like something we often think about. If it's a dy integral, then you do like right minus left, yeah? So in this case, the top is like, I guess, f of x, and the bottom is, there almost isn't a bottom here. I would just call it like, it's the x-axis. You could say y equals 0. So in other words, f of x minus 0, right? Which is, so yeah, just f of x. So that's what r is. And yeah, there should be bounds as well for your integral. And so the bounds are going to be x values because it's an x integral. And yeah, these are the x values that are like the boundaries of our region. So there you go. That's the full integral. And you do not have to evaluate it. So that's nice. And this is how I would write my answer. It's the exact same thing. And so yes, you literally can just write f of x. You don't have to write out the whole square root or cube root thing, right? Because f of x is just like the nickname for the cube root function. So you can always call a function by its name. All right, part C, now we're doing perimeter. This is interesting. So perimeter, length of that line, length of this line, length of, this is not a line, I guess it's a curve. That's going to be the hard part. But so the length of this vertical line is just 1, because literally this point is 2, 1. Okay, so 1, and then the length of the green line, that's 1. The yellow curve is the hard part. You're going to need arc length formula for that. So here's the arc length formula. It has a derivative in it, f prime of x. So you have to find the derivative of f of x, the derivative of that cube root thing. I wrote it underneath here in blue. So write it as an exponent. Do power rule. Now there is, I guess, technically chain rule here because you do have an inside of your function. And so you have to multiply by the derivative of the inside. However, the derivative of x minus 1 is just 1, so like the chain rule doesn't really like change anything here. So you throw that in there, and the bounds are 1 to 2, because once again, it's an x integral. 1 and 2 are the x, or are the boundaries that are x values, and that's it. because you do not have to evaluate. And my answer looks pretty much exactly the same. Yeah, I don't even write this as 2. I just kept it as 1 plus 1. You do not have to simplify. And finally, part D, we're doing an improper integral. So for improper integrals, first step, write it as a limit. If you don't write it as a limit, you're not going to get full credit. Now I need to do the antiderivative of this. So I just wrote the answer to it here, but most people would do a u sub here. So I put the u sub on the right. U equals the exponent. You end up with integral of e to the u, which we know is itself. Okay, at this point, then you plug in the t, you plug in the 2. So we could simplify this, although it's interesting to think about, do you not have to simplify this? Like, could you just carry this unsimplified chunk of math through all the steps because you don't have to simplify your final answer? I guess you could, but when I wrote this out, I simplified it. You end up getting a half, right? And then on the left side, I want to be able to do the limit of this. So it's probably easier to think about it if I write it as a fraction. All right, so t is approaching infinity, like t is 1,000 or t is 1,000,000 or 1,000,000,000, right? And so what happens to this fraction? Well, 1 is just 1. This is getting bigger and bigger, so I think we're approaching 0, right? If the denominator of a fraction is getting bigger and the numerator is not doing anything, then you're approaching 0. So the answer ends up being 0 plus a half or just a half. And then here's a thought about this part of the question, part D. This is also asking us to find area, basically. We found the area of this region that goes on like infinitely, but they did not phrase it as like an area question, you know. I think that's interesting. Here's how I write my answer. I guess I did simplify my answer. Well, all right. Well, the official solutions are not available yet because I'm recording this the day after they just released the FRQs. So as soon as the official solutions come out, I'll post a link to those in the description so you can compare my answers here, my step-by-step solutions here with the step-by-step solutions that will be in that link or in that document from the College Board. But all right, that's it for this video. Thanks for watching.